Howdy folks, welcome to another version of Houdini Secrets Live. Today we are going to be continuing with our procedural foliage lecture, and we are going to continue talking about how to make things a little bit fancier and a little bit prettier when we're creating our procedural foliage. We've got a pretty complicated tree that looks pretty nutty, but we're going to get things going looking as nicely as we can. So we're going to make some modifications to the tree branches. We're going to make some modifications to their lengths, and then we are going to add some actual barkage. And hopefully we can get through that by the end of the session today. And if that works, then we're going to be all good. But look at that. I need to turn this off. All right, now we have that fixed, so we should be good to go. Oh, by the way, the updates for this last week's project should be on the GitHub. And so if you go to the Orlando Houdini Users group, if you go to the GitHub for that, then you should be able to download that, and you should be able to download Advanced Trees 612, which was last lecture's, if you want to follow along. After today's lecture, I will go ahead and update today's content. I will create things for 619, and we will be able to use that as a fewer and forward-moving reference. With that said, let's get things underway. Now I'm going to transition back to my Houdini lecture. And things are going to get a little nutty here, but be not afraid. We're going to get things ready to go as quickly as can. All right, let's get things going. Aha! You can't see me anymore, and there is the Houdini screen, as expected. And I'm just waiting to get confirmation from my streaming from YouTube to make sure that you can no longer see my crazy-looking face anymore. And then we see the background. Aha, there we go. Okay, guess what? I am going to get naked. It is very hot in my bedroom. And so therefore, if I'm going to lecture with you guys for the next hour or so, then I want to make sure I'm as comfortable as possible. And so therefore, I am going to take my shirt off. Okay, we are good to go. All right. Now, where do we leave off on here? Okay, we left things off. We're looking pretty interesting. We've got our tree that's looking kind of gnarly here, but you'll see that the length of the branches are not real nice yet. They still need to be dorked with. Oh, just as kind of like as a dorking rule that can be considered as like you are free to manipulate any of these random functions that you can. Anything that deals with random, anything that deals with any function whatsoever, feel free to go ahead and play around with and manipulate however you want, because that's the nice thing about procedurality, is that it's up to the artist to kind of come up with these formulas and these various random features and manipulate them and discombobulate them any way possible in order to get them to look good. And so that's kind of like what makes a procedural artist the artist, is the way that they're able to use the formulas, the way they use the numbers in order to get kind of the desired look that they want. Okay, so what we are going to do right now is work on some fancy branches. Now suppose that we wanted to use a ramp to measure the length of it. Notice that we don't have a ramp on here. But what if we wanted to use a ramp in order to measure the length of the branch? And the branch length is going to be set to some kind of template node, but the branch position on the parent is set way back to the customer side. So what we need to do is go back here. So if we look down here, we see that our branch length is stored way over here, over in template. If we go over here, I'm going to expand this out. And then we have our trunk length in here. Here is our formula here. I might come back to this at some point in the future. I'm not real happy with the way this is working, but it's not broken at the moment, so I'm not going to fix it, but I'm still not happy the way it is working. We may come back to this, but this is where we set the trunk length information. But we need to do it proportionally to where the branches exist. So in other words, see these branches, they're at the bottom of the tree. I want these branches to be bigger than these branches way at the top of the tree, where they're going to be a lot smaller. And so what we need to do is get this U information from that, and that is in our homemade scatter. Now here's our homemade scatter, and there's the this lovely attribute wrangle. Now here's this U parameter that I'm talking about. Now this U parameter gets the starts at 0 at the bottom, and it goes all the way up to 1. And so this U is the parametric location of the branch on its parent. And so how do we get this U information from this formula all the way over to our branch template? This is going to require a little bit of manipulation. Okay, how are we going to get this? Well, what we're going to do is after the current point in this, we're going to add one more line of code here. We're going to come back to this on occasion, and we're going to keep things, so don't get too used to leaving things for this homemade scatter. This is kind of the brain, the nucleus of our entire procedural tree here, and we're just going to keep on making modifications. So after this current point, I'm going to create a new line here where it says set point attrib and what we're going to do is we're going to open and close parentheses, and the inside of it we're going to set it to the geo self. So that means we are going to add more information to the geometry itself. And what are we going to add? Well, we're going to create a new local variable called uval. So in double quotes, put in the value uval. And what we're going to do is we have to tell it which point number to actually put this on. So notice here that when we did add point, we returned the current point number. And so we are returning that point number. We're going to use that as an ID of identifying where we're going to set all future point references. So we're going to put that as current point. Current point. Okay, we've got our current point in there. So that means that that's the point number. And then we're going to add in our U value. So in other words, what we're doing is we are promoting the local U value inside of this function up to an attribute to the point. So let's go ahead and make sure that this works. I'm going to go ahead and I'm going to hit Alt, Enter. Okay, I didn't get any errors or anything. So let's see if this actually worked. I'm going to come over here to Scene View, and I'll hit plus, Pan Type, and I'm going to go all the way down to Inspectors where it says Geometry Spreadsheet. Aha, there's our uval. And our uval starts off at 0, and then it's going to go all the way up, ultimately, to somewhere near 1. Remember, we set the branches that we didn't want the branches to actually start until 0.2 and they go to like something 0.8. Where is that again? Let's take a look at that. If I go up, then we want our minimum branches to start at 0.2 and go all the way up to 1. And so we're going to get some randomness, somewhere between 0.2 and 1. And if we bring this down just a wee bit, there they are. Okay, so there it is. And now if we come back up into here and click under there, we'll see that the U value is equal to somewhere between 0.2 to 0.93, somewhere in there. And let me see, do we have anything that's up to 9.3? I don't see anything yet. Alright, so we're probably good to go. Okay, so that means now this U value is now a point property all the way. So that means this point property is going to go through all the way down to where it says copy to branch. Now if we go to copy to branch and click this, does the U-val make it through? Okay, no, it gets lost in translation. Okay, so what we're going to have to do is we're going to have to so we've got that going. So okay, we're going to be doing okay. So what we want to do now is we want to add some kind of controls to our interface in order to deal with the new fancy branches. So I'm going to come back up here. I'm going to right click on my TreeSop node, or my TreeGen node, right click and go to type properties. Alright, we've got our type properties windows now. So let's take a look at our parameter interface. So here we're going to go off of branches. And so what I want to do is create a separator and kind of like create a separation between the abstract branches and the branch length, because this is really just about branch length. So I'm going to grab a separator and drop that right into branches. And you see it automatically deposited right at the bottom there. I'm going to grab a label, just to get a little bit more separation. Label. I'm going to drop that into branches. Oh, so it's sitting right underneath there. And I'm going to change my label attributes to be fancy branches. Fancy branches, and my label, fancy branches. Oops, spelled wrong. Alright, fancy branches. Alright, I've got that separator going, and now what I want to do is I want to drag a folder sitting underneath that. So I'm going to drag this folder underneath branches, and I want this folder to just deal with branch length. So I'm going to call this branch length, and I'm going to give the label name the exact same thing. Branch space length. Alright. And now I've got it in here, so I want to put my ramp so that it exists right here under that. So look over here where it says ramp float. I'm going to go ahead and drag this and drag it right underneath the branch length folder, and I'm going to call this guy branch ramp. And I'm going to call this branch ramp. I'm going to go ahead and hit accept. And you see this changed our interface. Here it is, our fancy branches. And now what we're going to do is okay, look at this. The branches, that means that at the bottom they're going to be small, and at the top they're going to be big. So I'm going to change this around so that it's the exact opposite. So it's going to be big at the beginning and small at the end. Alright, there we go. Okay, that branch length is now going to control the length of our overall branches. Okay, we're going to drop back into our SOPs. Okay, now with the copy to branch points, what we're going to do is we're going to create a brand new stamp variable. And this new stamp variable is going to be branch length ramp. Branch length ramp. Okay, its value is we're going to create a function here that's going to use that U-val value that we created earlier. And let's see, where do we want this? Okay, here we have this switch here. It's switch 1 here. So we're going to remember that this is a good place for us to reference in. So I'm going to hit Alt-E to bring that up and make it look a little bit easier. So we're going to go, okay, now we're going to do a CH channel, but because we're accessing a ramp information, we have to use a different function. So we're going to use CH ramp as our function to get our information from the interface. And like any other CH, we have to tell it what where we want it to get it from, and we're going to get it from the branch ramp variable. So open and close quotes, and then inside you're going to go // branch ramp. All right, and now what we have to do is tell it what point that we want in there, and we want the U value in there. Now we still don't have that value because it didn't quite make it in here, but what we can do is we can access, we do know that the U value is still sitting here right over in the switch stop. So what we're going to do is we're going to cannibalize and kind of tap into that switch stop and say, okay, get us the U value for the current point. And we'll do that with a point function. Point, open and close parentheses. Inside of that, go open and close double quotes, and go // switch 1, that's the name. And then we have to tell it which point number that we want. And we don't know that, but it's stored within this variable called $PT, all in caps. And then we want it to tell us, okay, what parameter or what attribute of that point do we want? We want our U val. That was the one that we set inside of our custom-made scatter node. And then we're going to give that a value of 0 as way of default. And then we're going to need to put a 0 here to make sure that that is functioning. So I'm going to go ahead and hit apply to make sure that this all works. Uh-oh, syntax error. It says unable to value 2. Okay, CH ramp. So I have a hunch that it's probably here with this point statement. And so let's get rid of that X. And so if we were just to put $PT, well, let's just put some kind of value of 0.1 in here. Now, is this going to work? Okay. The CH ramp, okay, I'm not sure how the context of CH ramp is, so I'm going to look at the help, and I'm going to look up CH ramp. Obviously, my parameters are not working here. So, CH ramp. Oh, okay, so there's some time in there, the float time, and so the ramp position in the string channel. So let's make sure that our title is branch ramp, and here, and I don't think we need this number here. And is this what's causing our problem? Nope. So we've got some kind of other value here. Oh, I don't think we need that. Is this what the problem is? Aha. Unable to, for function, invalid number of arguments. So let's put that comma back up in there. And the 0. Is this what it's looking for? Aha. So it is working. All right, good. Well, we've got that, our CH ramp function working properly. So let's go ahead and put our point in there. So point. Let's see, I pasted that, so let's see if that still works. Okay, good. Apply. Okay, good. No errors, so we should be fine. So we got some kind of value in here. Okay, good. So branch length ramp is the name of our stamp. So let's go ahead and modify our branch length according to this new stamp variable. So here it is. I'm going to go branch template. And here's my big long function. And so I'm going to go ahead and hit Alt-E to get this in here. Now, see this big result? Honestly, I can't remember what the result of everything going from here. But what I can remember is this whole thing is going to get. And I can't remember what it is. So what I'm going to do is I'm just going to multiply my branch length ramp against whatever the value is here. So I'm just going to say, okay, stamp times there. Okay, what's going inside this stamp? Okay, we have to go from our copy to branch points. So double quotes inside of there, and we're going to go // copy to branch points. That's the name of our stops. To branch points, copy to branch points. All right. And then we have our branch length ramp. That's the name of our variable. Branch length ramp. And we want to give it a default value of 0.0. Bad parameter ramp. It's got to be in parameter temple districts. Okay. Copy to branch points. Copy to branch points. Bad parameter value. Bad parameter reference. Copy to branch points. It doesn't like that path. Branch length ramp, I know that that's fine. All right, I'm just going to drop this again here. And then hit this. Alright, is this going to be better? Unable to evaluate bracing error. Okay, so we are not doing, oh, look at that. Alright. So like that. Alright, everything should be applied now. Okay, we're getting some interesting results. Check this out. Okay, our branch length now is maintaining a weird position. Okay, so let's take a look at this. So the branch lengths are going to be longer at the bottom and shorter at the top. Let's look at this. All right, suppose we wanted to go and manipulate these values. We'll pull that up and we'll see that they grow up bigger. And so now they're the same length from the beginning to the end. And now here, the ones at the bottom are smart. Now we can add points in here, and that will manipulate the points along in here. Now we can change our interpolation. Currently it's in linear. We can change that to Bezier, Bezier, and then we can create some curvature here. I don't want a Bezier. Come on, give us some Bezier action here, or try B-spline. Let's get some curve. All right. So there we have some curvature. And so we can add some funky values in here depending on how we want this to look. Okay, cool. So that will give us some kind of manipulation or way to control the length of our branches in relative respect to the entire tree. All right, I'm going to go ahead and save this. And this is 619. Okay, good. This will be up on GitHub after the session today. All right, now, as an extra bonus, there's lots of stuff that we can manipulate on here, and there's just too much to go into. And if anyone has any questions on how to manipulate any particular aspect of this system, please feel free to go ahead and contact me either in, oops, wrong thing, either in with the chat or in the email, and we'll try to get answer your questions you can. I just took a look at my chat and I realized there's nothing on here. So what we're going to do here is we're going to add a little bit extra. Now suppose that we want to be able to add extra length to our branches, but we don't want to manipulate the actual trunk value itself. So what we're going to have to do is create an offset to our branches so that we'll only update our branches and it won't update our trunk. Okay, so let's go ahead and up into our type properties and add that. Add that parameter value. Okay, I'm going to go right click on TreeGen, go into type properties. All right, so here we have a branch length, and I'm going to add a float value in here, And this is going to act as an offset that will offset all of our tree branches and leave our trunk exactly the same. I'm going to drag that off in here. I'm going to insert that right between the branch length folder and the branch ramp itself. I'm going to change the name. I'm going to call this branch length offset. Branch length offset. And I'm going to call this branch space, branch length offset. All right. I'm going to go ahead and click accept. And we see we now have a new parameter that's sitting right up here, and this is going to provide us our offset value just for our branches. And we're going to go to the copy to branch points. We're going to create another variable in here, and we're going to call it branch length offset. Okay, now we're going to add just a little bit of logic. I'm going to put my cursor in there. I'm going to hit Alt-E to get in there, and I want to get rid of that 0 because we're going to put in a little bit of logic. So we're going to put it in the variable if statement. And an if statement has 3 sections. So if you're going to have, something is going to have a 0 or 1 value. And then if it's 0, if it's 1, then it's a, so here let's take a look at this. If we have values of inside A, comma B, comma C. This is how Houdini reads that. It's going to read A, and if A is anything greater than 0, then it's going to take on the value of B. So it's going to return B. If it is 0, then it's going to return C. And that's how we're going to use it. So what we want to do our evaluation, we know that we have on our spine information, we have an iteration counter, and that's going to keep track whether this is the first object or not. So if CH, okay, open and close parentheses, inside open and close double quotes, .. slash spine info slash iteration. Okay, so here's our, remember, if it's the first one or it's the trunk, it's going to be a value of 0. If it's going to be anything greater, then it's going to be something greater than 0, so it's going to go, so by default, this is going to say, okay, if it is greater than 0, then do this statement. So A, then we want our branch length offset. So CH, and let's get this from the interface. So open and close quotes, .. slash branch length offset. Okay, and if the value is, if the value is at the trunk, then we want this thing to just return 0, because then we don't want anything else to change. All right, let me click apply. All right, no complaints. All right, now if this is a value of 1, spine length info, iteration, spine info. All right, so let me make sure that this is all spelled correct. Spine info, iteration, copy parameter, and I'm going to paste the relative reference right in here. Okay, .. says spine info slash iteration. Okay, apply, accept. Okay, hopefully that's all working. Okay, it's returning 0 right now, which concerns me, but let's see if this actually works here. All right, so we're going to go to our branch template here, and then we're going to revisit this. Okay, remember we just multiplied stamp times everything else. Now what we're going to do is we're going to add another stamp, but we're just going to add it to that. So this is going to be just like an offset. So I'm going to copy this statement here, and then I'm going to insert it right in there, and I'm going to add it to my old statement. And so we're going to go copy, stamp the branches out. Instead of branch length ramp, we're going to use branch length offset. Okay, click apply. All right, and so it should work now. So everything looks fine. So let's come up here, up. Okay, now branch length offset. If we extend this, and you see that our branches extend the length, but our trunk stays exactly the same. Okay, as you can see, we have a pretty good control over some of our ramps, over some of our lengths of our trees now. All right, great. Let me go ahead and save this so we don't forget it. Now let's keep on moving forward. All right. Now, there's one thing I did forget. Now, we forgot to subdivide the branches. Because if we turn on the points here, we see all of our branches that are only 2 points long. Now, if we're going to put bark on here, we're going to need a lot more information than that. So let's go ahead and subdivide our branches. So where it says branch template, and then where it says points, I'm just going to, so we created a trunk points parameter last week. And remember, if we look over here to trunk, then we have branch points, trunk points. Now it's 40. So that's way a big number. And so I'm just going to keep things a little bit copacetic here, change that to a value of 20 so that we don't have too many points here. And hopefully we should be okay. And I say trunk segments, we're going to change that. We're going to change that to 8 just for now. Better to have too little than too many, because you can always add more. So here, where it says branch template, for the number of points, what we're going to do is we're going to do a reference to our trunk points variable. So ch, open and close parentheses, inside of that, open and close double quotes, inside of the double quotes, / trunk points. That's trunk points. We want trunk points. Okay, so now it's trunk points. You see that it didn't change here any. Our tree didn't change anything because all we did was we inserted the number of points in between all of our branches. So if we turn on the number of points, we see that we now have lots of points in there in the middle. So now we have stuff to work with, because the strategy here is that now that we have points in all of our branches, we now can add skinning information to actually create a skin around it. There is a whole bunch of stuff that we can add along the way that I didn't include. Now this is something that Jerry included as iteration again, but if somebody has any questions on any kind of customization that we might want to do to this network, please feel free to come and ask me or send me a text at any old time, because I will go into more of the details on how to customize this even further. But as the things are going, let's go ahead and clean things up and get ready for our trunk. So after we have the spine end, let's go ahead and put a null on here. And we're going to call this one, we're going to call it trunk and branches. Trunk and branches. All right, I'm going to color this, so I'm going to hit the C. Whoops, I'm going to get rid of my parameters. I want this colored green because I like the color green. That means we're good to go. And I'm going to get rid of this color palette, and then I'm going to hit Z, and it's going to give me my shape palette. And because this is all going down, I want this to kind of like act as like an arrow that's all going down. So I'm going to change the shape of my icon to be that so that we know that it's all going down. Okay, I'm going to hit the Z key to get rid of my shape palette. I'm going to select all of these, and then I'm going to hit the Shift O, and that's going to create a network around the whole thing. And I'm going to say trunk and branches. Okay, now we should be good to go. Now this is now a good group. Now we can go ahead and make changes to this in the future, but now we can manipulate on this as a whole. So now that we've cleaned things up a little bit, let's give ourselves a whole bunch of bark controls. So let's go back up to this level, right click on our type properties, and now last week I forgot to create a parameter list for our bark. You know, just plain old forgot to put it in there altogether. So what we have here is we've got a folder for a trunk, we've got a folder for branches. Let's go ahead and put in a folder here for bark. So I'm going to grab a folder here and drop this in shape. So we're going to call this bark. Okay, now I have a bark folder, but the bark folder here chronologically is after leaves. So according to our, you know, if we were reading left to right, we would go to trunk, branches, leaves, then bark. But we know that we want bark before leaves, so let's just grab bark and push this so that it goes before leaves. And then let's work with that. So that should work. Okay. Now, we know that our bark has a kind of a base width that we want to act as our tree here. So I'm going to grab a float and drop that in bark, and I'm going to call this bark base width. Bark base width. And I'm calling it bark base width. Okay. Now, for this, now we didn't do this before, and we probably should have, but I'm going to show you guys how to do this. We're going to control the range. So I want my bark range to always be at least 1, and somewhere, like, anything larger than 20 is out of hand. Can the user go ahead and change this to something something smaller than 1 or larger than 20? Yes, but it's just going to be a little bit more difficult for them. And so for now, this makes this channel just a value of 1, just to make it something manipulatable. All right. Now, inside in bark, we're going to create another folder because I really like working with ramps. And so let's add some more ramps in here. I'm going to grab this folder here and drop this in bark. Okay, so what are we going to call this? We're going to call this the width ramp. So what we are going to do, and this is a width ramp, and we're going to call width ramp. And so what we're going to do is we're going to drop a ramp in here, and I'm going to drop that right at the width ramp, and we're going to call this width ramp. And what this ramp is going to accomplish is that it's going to, from the beginning of the branch to the end of the ramp, it's going to control how thick the branch stays. And we're going to manipulate this. So I'm going to click accept. And if we go here to bark, okay, here it is, our width ramp. Here's our base width of 1, our width ramp here. It's going to start off skinny and then get thick. I want it to start thick and then go skinny. Okay, good. That's what we want. That'll give us some good direction. All right. Now we're making progress. All right. Now, just as this null is the bottom or the end of our trunk and branches, we're going to want to create a null for the top of our bark. So I'm going to drag this off here and drop in a null. and I'm going to call this bark top. Oh, let's call it bark input actually. Bark input. Okay. Let's go ahead and why green means good to go. I'm going to put yellow in as input, so I'm going to click that, click there, click yellow. Come on. Make me yellow. There you go. Alright, I'm going to get rid of my color, go to my shape palette, and just as the opposite, I'm going to make sure that this has the input from there. Okay, so this one funnels down and this one opens up the funnel. So bark input. Alright, get rid of that. So now, remember, each one of these branches is now its own specific parameter or primitive. So what I'm going to do is, we're going to do the same operation is we're going to apply a skin to each one of these primitives. So we're going to use a for each primitive. I'm going to right click in here, I'm going to go for each, and here it is, for each primitive. And here we go. I'm going to drop that in there. And where it says for each begin, I'm going to change this to a bark begin, bark underscore begin, and change this to bark end, bark underscore end. Alright, and then the input of that is going to come right into here. Alright. So the first thing we're going to want to do is we are going to want to manipulate our ramp information. So let's start with right with our information and get that information right from our interface. So I'm going to drop down a point wrangle SOP. And I'm going to call this to set attribs. Set attribs, because for our bark, this is going to be our main SOP to set our attributes. Alright, let's enter in some values here. So we're going to start out, we might come back to this further on, but we're going to start out with just one simple statement. We're going to say f at width. Remember, what this means here is, since this is a vex, that means we're creating a float variable, and we'll go at width. That means create a new attribute, and this is going to become part of our primitive. So it's going to get a new attribute called width, and it's going to go chramp. All right, and that's open and close parentheses inside open and close double quotes. And then we're going to go width ramp is / width ramp. And let's see, what kind of information do we have here? Oh, we want our U-val to this. So we get this U value here. So if we click on here, there's a geometry spread here. Okay. Yeah, okay, so we don't know quite what that is yet, so our ramp value here. So what we're going to do here is I'm going to go ahead, I said I wasn't going to change this, I'm going to change this just a little bit. So I forgot, I'm going to add a U value, because this U value is going to be where our U coordinate for our texture map. So float at U equals at ptnum, which is short, this is vex for the point number, the current point number, divided by, and here, open and close parentheses, Make sure to put that in there. And inside the parentheses, we're going to go at num point, or n num pt, which is the number of points, minus 1.0. Okay, make sure to put that as 1.0. The reason why we want that as 1.0 is because this is doing a division, and pt num is an integer, and num pt is an integer also. But most probably, this value is going to be, this lowercase value is going to be bigger than this value. And so it's going to end up as a fraction. And if it was an integer divided by an integer, we'd end up with 0. And that's not what we want. And so we're going to take that u value here, and we're going to stick that right in here at u. All right, put a semicolon in there. I hit Alt-Return. Do we have any errors? Okay, no errors, so let's see if that's coming through. We should have two new variables, u and width. U and width, there we go. All right, so this is our first, and so u kind of goes all the way up to here, and then width, more or less kind of goes in the opposite direction, but according to our RAM. Okay, cool, we have things working. Okay, now what we have to do is create a bark template. And our bark template is simply going to be just a circle. Nice and easy. Circle. And change the primitive type from primitive and make it a polygon. And so the number of divisions, didn't we create a parameter for that? Let me look up here. Trunk segments here. Yeah, so this is trunk segments here. So that's what that equals here. So here for the divisions, we'll go ch, open and close parentheses. Stick it here, open and close double quotes. Trunk divisions. / trunk divisions. That's not right. Trunk divisions, okay, that's not right. Trunk segments. So I'm going to copy this value, copy parameter, and then I am just going to stick it right in here. So paste relative reference, trunk segments. Okay, is value of 8. Okay, good. We have everything set as it should be now. All right. And let's call this guy bark template. Okay, our bark template is now ready to boogie woogie. So let's copy, for every one of these points now, we want to copy one of these circles onto the place. So we're going to drop in a copy stamp sub. Copy stamp. I'm going to drop that in there. And we're going to call this copy rings to points. Copy rings to points. Okay, that's what we're going to be doing. Set the input 0 to the bark template. This is what we're going to copy, and this is where we're going to be copying to. And then we're going to connect this to the block end. Alright, so let's click the C. Alright, this is going to get really complicated really quick. If we click this, okay, we got one thing going here. Alright. So this is all good, and if we click this, okay, this is going to get too complicated quickly. So what I'm going to do is I'm going to go back up in the interface and make things a little simpler on myself for this tree gen. So for the branches, the number of branches for the level is 3. I'm going to change this to 2 and 1 so that we just have to deal with that. Okay, we have an interesting problem. We copied each of these circles to every one of the points, but they're pointed in the wrong direction. They're got the orientation wrong. So we have to go in and align our normals. So let's go between the bark top or our bark input and begin. So let's go ahead and put in a polyframe stop. Now the I lost it. Polyframe, there we go. Alright, the polyframe stop does some really cool things. We're going to call this align normals. So what this is going to do is it's going to follow along the direction, and it's going to create a normal, and it's going to create a binormal, and it's going to create a tangent and a bitangent. So let's go ahead and enable this. So our normal name is we're going to call this side, and our tangent name we're going to N, and we're going to give a bitangent is up. Okay, you look at that. As soon as we change that, our circles stacked right up just like stink. Alright, that is cool. Okay, but now these circles are of the exact same length, and we want it to get smaller. We want it larger at the base and smaller at top. So let's go over here where it says the copy rings to points, and let's, just like we did for the branches, let's go ahead and create stamps in order to carry that information forward. So I've got my copy to points, click on the stamp folder, make sure to click stamp inputs, and so we're going to create the first variable, and we're going to call it a bark width. Bark width. And its value is we want to get the width value coming in from here. So let's go ahead and Alt-E, we'll put that in there, get rid of the 0. So we're going to use the point stop in order to get that information. So point stop, open and close parentheses, open and close double quotes. Inside the double quotes, we're going to go / set attribs, and then we want the current point number, so $PT, and then we want our width parameter, and then we want this to be default 0. Alright, click apply, accept. Okay, cool. We got that going. So our bark template, then where our uniform scale, and we're going to go stamp, and then we're going to go to our bark width parameter that we just created. So Alt-E, I'm going to erase this one, so stamp, open and close parentheses, open and close double quotes, / copy to points is the name of the SOP where this is all kept. And then we're going to go bark width, open and close double quotes, bark width, okay, and then that's our parameter, that goes 0. All right. I'm going to click apply. Oops, bad reference, copy to points. Now it's copy rings to points. Click apply. All right, so we hope these are good. All right, cool, look at that. Now, we can see our rings, they're large and they get small as they go up. That's exactly how we want it to behave. So let's test it to see if we add more levels. Here's the second level, and there's the third level. Okay, we got a little bit of a problem. They're all starting from the same length, and they're all getting smaller over time. So they all start from the same length, and they are good. So what we need to do is these sizes that the bark starts at needs to inherit its parent's relative position. So that means we need to access this U value again along the, or this distance along the branch, and then we need to use that U value to modify the width of our branch in order to start with. But our branch width has to go from like, instead of going from 1 to 0, now we want it to go from U down to 0. All right, so this is, I'm not going to have time to go into the full thought process on this, but this is going to take a little bit of initialization, because what we have to do is get things started with the trunk first, because the trunk is going to start things off, and everything is based on things. And what we're doing is we're actually creating a kind of recursive neighbor. That's why we have to start with this trunk. So we need to initialize what our bark scale is. So insert an attribute create SOP between the trunk normal and the trunk end. So we're going to go, whoops, that's not what we wanted here. Okay, no. Screw you. And then we want to create an attribute create. Attribute create. All right, there it is. Here's our attribute create. We're going to call this bark scale. Because here's our initial bark scale attribute. And we want the default value to be 1, and default is 1, and the value equals 1. All right, now insert that in here. Okay, I misspelled the C. That's a lowercase. So here's lowercase c. All right, now we go to copy to branch points. And now here's the nutty part here, where it's copy to branch points. We go to attribute. Now you may never have used this before, and this is like, I don't use this a whole lot. What it does is, so I'm going to say use template pointers, and it exposes this. So what this does, it looks at the source and says if it has these values, then if it has the point values, then if it has like alpha or V, then it says set. Okay, we don't want to set our bark scale. We want it to multiply. So there is a multiply. So we don't want the bark scale to do anything here. So we're going to say not bark scale, and you say that by putting caret bark scale. Okay, so therefore we are not going to use the bark scale parameter. Okay, for the set, but we are going to use it for the multiply. So I'll put comma here, bark scale. All right, so it is going to multiply on through. So that means it's going to use the original bark scale value, and it's going to pass it right on through. All right, so there's one more place that we need to modify our bark scale, and that is if we go back to the homemade scatter. Let's see. Okay, we're going to add it between the point wrangle, between branch template, and copy to branch points. We're going to add a point wrangle here. Point wrangle. All right. And we're going to call this initial bark scale. Double click this. Initial bark scale. Okay, what are we going to set this initial bark scale to? I'm going to say F to our floating value at, that means it's a new attribute, I'm going to call this bark scale, and we're going to say equals. Okay, and so what we're going to do is just give it a gradual progression, is that the bark scale is going to start at the base and it's going to get small. And we're going to start off just by creating the ratio of $PT, $PT num divided by, open and close parentheses, num PT minus 1. So at num PT minus 1.0. Remember, make sure that is 1.0, not just 1, because otherwise it will be treated as an integer and not as a float. So let's see if this is working. All right, no problems here. I'm going to go ahead and click this, and let's see what his values are. Okay, so our bark scale is going 0 to 1. Now we want this to go in the exact opposite direction. We want it to go 1 down to 0 because we want the bark to start off big and we want it to get that. So what I'm going to do is I'm going to click this and I'm going to say 1.0 minus. Alright, so it's going to be, it's going to effectively flip that. Okay, there we go. It's now flipped, and so now our bark scale starts at 1 and then ends up at 0. Put that right in there. All right, now that we have that, so let's go and modify. This is just as far as the bark is concerned. Now we have to go and modify inside of our loop here in order to get this all working. So we need to multiply the new bark scale, which is going to go between 1 and 0, against the new U value, so that the bark scale goes from the old U value down to 0. So in this custom, inside of this custom scatter, we're going to have to add something here. So here's our homemade scatter. And we're going to have to add something a little bit to the very end here. Okay, we got that going. So we're going to go, just like we did with prim attribute here, P, what we're going to do is we're going to access the bark scale value. So if we have, we need some kind of variable to hold this. So I'm going to go with a point bark scale. So I'll click up here, I'm going to say float P bark scale. Okay, so that's going to contain our bark scale element that we're going to get from the editor. So we're going to go prim attribute, prim underscore attrib, oh no, it's attribute, open and close parentheses, and so we're going to say at op input 1, op input 1, and then we're going to put this as a result into our P bark scale value. So P bark scale, that's where our destination is going to be. And we want the bark scale amount. So bark scale. And this is going to give us the primitive number that we're dealing with. So at primnum, at primnum, okay, and we want the value of U and the default value of 0.0. Okay, we got a semicolon around that. All right, now we've got our P bark scale, our value in there. So now we have to set this as a point attribute. So set point attrib, oops, that's a lowercase, attrib, open and close quotes, open and close parentheses. Inside we want geoself, open and close parentheses, comma, and we want the bark scale value. This is what we want to set it to, so bark scale. Close that, and then we want the current point, and then we're going to want our p-bark scale times view. So p-bark scale times u, our u value. Okay, so let's go ahead and make sure that that has a semicolon there. Is this going to give us an error? So we're going to hit Alt and Enter. Okay, set attribute point. So it doesn't like this. So at, I can't even remember what that is spelled like, so I want to make sure it's spelled C and V. Alright, so this is what our value should be. So I just noticed that my OBS here was disconnected. I do not know why that happened, but it disconnected it. So I'm going to make sure that I'm still recording. Okay, it says I'm stopped recording and I'm still recording, and the record length is 1.8. So let's see if we are still connected in here. End live stream. I think we're still streaming. Excellent condition. So everything looks like everything is going fine. Okay. I don't see any unable to connect to chat. Please try again later. Okay, so is that okay? End stream. Everything's going right. Create highlight video. Okay. Share live stream. Okay, everything seems to be fine. If somebody if this is not working correctly, please try to get back in contact with me, and I will make necessary adjustments if need be. All right. So here's our adjustment. So we currently now should have everything ready to rock and roll. Aha. All right, cool. Looks like Emma's getting some progress. She lost Houdini earlier, and so we're trying to get it back for her. Anyway, so inside of our loop, we should get this. All right, good. So now let's go into the copy rings to points. So here we got that. Okay, good. I'm going to make this a little smaller to give myself some breathing room. Okay, where it says copy rings to points, and we have bark width. Now what we're going to do is multiply bark scale by my bark width. Okay, so we have this value here, and I hit Alt E, and so it has set point derivatives dot B. This is the width. So let's multiply it by our bark scale value. So point, open and close parentheses, times, and then I'm going to insert in here, open and close double quotes. And then we want to get our bark scale value from our set attributes. So it's // set capital A attributes. All right, there's our SOP that we're going to get it from, and we want $PT to be our point, and we want our bark scale value to be coming in. So open and close quotes, bark capital scale. All right, and as an initial value, we want it as 0.0. Okay, we got it that good. So if I click apply, everything is okay. This looked like okay. Everything is like we've got back to there. Okay, this is looking sexy. All right. So now let's see if this actually worked. So we've got that all going in the right direction. So let's add ourselves to our branch levels. Okay. So we have our branch levels here. So everything is No, okay, so we're missing something. All right, so we are missing something on here, and we lost all of our branches. So that means something isn't correct. So that means we're going to have to debug this system. Oh, that's too bad. I didn't incorporate any kind of debug time, and this might require some additional debuggingness. But that's all what we get from live entertainment here. Okay, so we have this bark template, so let's see if we can align in here. So it's going through once, but it's not going through multiple times. All right. So this should go through multiple times. So we got this value here where we have our individual. Okay, how many polygons do we actually have? I'm going to click on here. Okay, so there's 93 primitives. Oof, that's a lot of branches. Let's make things a little bit simpler. And 93 branches, that's a lot. But we're going to go through this 93 times. Oh, that's crazy. So let's go through and make this a single pass. All right, so we have a single pass. All right, so let's happen if we go through this. For the single pass, we go through this. So let's go through the double pass. Now something happens here. We lose value here. And so what happens here? Our uniform scale drops to 0. Okay. So inside copy rings of points, and we have our bark width here. Okay, so our variable in bark width here. So that goes to 0. All right. So as we go this, the Houdini is burning inside of the fire. Yeah, the fun never ends. It just keeps on dragging. Okay, something's happening so that our copy rings to point is getting dropped to 0. Our bark width for this is 0. So let's see what's going on. Okay, so our bark scale is multiplied by a point. So our set attributes has and we know that our width. So let's check out our width value and our bark scale. So close. So here's our value for set attributes. Let's look at our geometry spreadsheet. And it looks like our bark scale is 0, but our width is right. So we have to backtrack and find out why is our bark scale 0. I'm going to click this up here, and here, look at here, we have bark scale here, and it's starting off at, here we got values here. Okay, so it looks like bark scale got created the first time, but it didn't propagate there afterwards. Okay, so we've got our forensic digging on here. Let's make sure that this is all working here. So I'm going to click up here, and I'll click over here to 2. And we've got click 1. All right, branch levels here, 1. All right. All right, so there's our point there, and okay. So let's double check into here. We go into switch, and this is coming into here. So it says here that we are not getting any kind of bark values here, bark skin. Okay, so that might be the reason why things are not working, because we don't have anything in here. So if we have a switch, so let's go back up here. Do we have anything here for bark scale? No. All right, come up here. Do we have anything for bark scale? No, so our attribute for bark scale isn't working, but we do have one called attribute. So let's change this to bark scale. Okay. All right. Now we have bark scale here. Does this have bark scale? Yes. Does this have bark scale? Yes. Does this have bark scale now? Yes, it certainly does. Okay. And what about this? Yes, it does. Okay, and now we go into here, and bark scale is now looking kind of good, and it is propagating. So is this the culprit? Okay, so this is still not playing nicely. Copy to branches. We have bark scale. All right. Bark input. Align normals. Okay, we have bark scale coming through here. Okay, I know what this is. Get rid of that. Okay. That kind of made things sensical. Okay, click bark begin. Okay, we have bark scale coming through. We have attributes. All right, now we have bark scale. Now we have this. Do we have bark scale in here? Uniform scale, and it's still 0. IJI. Okay, so bark width is still being multiplied to 0. So that means this value here, bark width, is still coming across as 0. All right, so where is our, oops. We still have to find our culprit. And here's a bark scale, and do we have width? Yeah, we still have width. So let's see if just width works here. So I'm going to click up here, point E. So I'm going to go and make sure that we just have width. So I'm going to click X here and click apply. All right, do we have anything here then? Now let's check our uniform scale, and it's still 0. All right, so our copy is, so something is going on with our, so set attributes, and we need the value of width and point PT. So this is not coming through, but width is being set here. Okay, width is coming through. So what's up, guys? Oh, because that's the first one. Okay, because this is the last one. Okay, I get it. All right, so if we click close here, then this should, if all is going right, look correct. There we go. All right, cool. Now, if we were to turn on multiple levels, is this going to be working properly? Okay, we've got branch level 2. And look at that. The branch levels, they are smaller, and as we go up, they are getting smaller. And so if we go into 3, and they get I don't know. This isn't looking like what I was expecting. All right. So something is still amiss here. Okay, at least we got, oh, I know why. All right, so let's go back into here. Go to copy rings to points. So we've got here, this is where we left off, and then we have to multiply bark scale. So I'm going to copy this. So we should have our bark scale parameter. Hit D times, and so width we want bark scale. B-A-R-K-S-K-C-A-L-E, bark scale, apply, okay. Oh, and it is smaller than I expected, so is there one thing that I forgot to do up into here? And in this homemade scatter, okay, this U is going in the wrong direction. And what I have to do is set it into the right direction. So I'm going to put parentheses around this U. And then I'm going to say 1.0 minus U. I hit Alt, Enter. And it's still not functioning correctly. Okay, I am going to have to figure out what is wrong with this and make the necessary adjustments. Something on this is very wrong. This is kind of a delicate procedure, gang, and I'm not kind of surprised this happened, and I'm not exactly quite sure why this is not manipulating. So let me make sure. Let me double check this again. Oops. Okay, so point attribute is bark scale, P bark scale times. Okay, so what's my P bark scale? Is that coming through? Click on here. Okay, we've got our bark scale. There it is. Something is misspelled. So we have bark scale with a capital C someplace. Okay, so somewhere one of our plays is spelled wrong with a capital C. I bet that's it. Right here. Scale. Right. Bark scale. Okay, so this is still bark scale, bark scale. Alright, so this is still not right. So here, bark scale, alright. And now let's check this copy to branches. Is this bark scale? Okay, so click here at spine end. Alright, so we got rid of the bark scale here, but do we have bark scale here, copy to branches? Bark scale, okay. And what about this switch here? Do we have a bark scale, initial bark scale? There it is. And how about this one? Bark scale? Okay. Here? Okay, nothing. Last. Okay, here. Alright, so hopefully this got rid of it. So we go to the scene view. Aha! That was it. Typo, error, in the extraordinary. Okay, now look at this. Our bark scale is working, and you'll see that the bark scale gets smaller as we go on through the branch, so it just gets propagated right on through. This is the dicey part of dealing with fractals, gang. You can get into a headache trying to figure out what went wrong. But we got everything working right, so quickly save! Because we don't want this to break anymore, but I can breathe a little bit. I don't have to sweat so much. Okay, so this is it. So, okay, we've got our good. So let's start skinning this bark. We've got our rings. So let's start skinning the bark. Okay, so what we're going to need some UV coordinates. So let's go back to our set attributes for this, and let's give ourselves some UV coordinates. So we already have our U value here, and that goes from at point num divided by this. Okay, so that's good. So this is our this is our U value. So let's go ahead and add some V values here. So add this bark template. I have and add a point wrangle. Put that in there. And I'm going to name that set V. Set V. Alright. And so we're going to do the same thing that we did with U. We're going to say F for float at V, so it's an attribute, equals at point num, at pt num, divided by at num point and pt minus 1.0. Okay, I'm going to hit Alt Enter to make sure that works. Let's double check to make sure that this is indeed going from here. I'm going to go click on here, click on my spreadsheet, and my V goes from 0 to 1 over 8. Okay, good. We now have some UV values that should go automatically through. Alright, cool. So let's make a UV attribute here. Because we have our U, we have our V, but we need an attribute called UV. So let's make another point attribute here. I have to copy the rings. Point attribute. Point wrangle, yes. We got our point wrangle, and we're going to say make UV attrib. Okay, actually, I'm going to do what I was saying. I was going to call this create UVS. Create UVs. Alright. I'm going to make sure that this works. And I'm going to say V. Okay, because this is going to return a vector. And this is, believe it or not, Houdini likes its U and V coordinates to be a vector. So that means it's got 3 values instead of 2. So at V, so V at UV, that's the name of the parameter, that's the way Houdini likes it, equals, now set. Remember, set is a way of defining a new variable when inside vex, and it's kind of like creating the new value inside C# or C++, and it just pulls in a new value. And so we need 2 values on here. We don't need the third because it's going to define it to whatever it is. So what we're going to do is we're going to get F at V times CH, and then what we're going to get is the UV scale from our interface. So open and close parentheses, open and close double quotes, dot dot slash UV capital scale X, and we want that as their U value, and then as our V value. So F at U times, and then we can do the same thing, CH, open and close parentheses, inside open and close double quotes, dot dot slash UV scale. And now in this case we want the Y value. We got X and then Y. Okay. So Alt Enter, and no errors. Okay, that's good. Are we getting what we want? So we have our UV value 0, 1. Okay. Okay, this isn't exciting. They're all value of 0. So that's not what I was hoping for. But do we have U and V values? So we've got V values, but we don't have any U values. Okay, so let's see where are our U values. Because we're coming across here, we have V values coming across, but we don't have any U values. Copy rings. Okay, we got here. Copy the rings of point, and we do have U values. So do we have to propagate this? And then so it says attributes, point add, and so set. We want this to come through. So do we want this to be U? So is that why we don't have anything? Okay, there's our U values. And there's our V values. And then U and V are still 0. Oh, I know why. Okay, still not quite there yet, so go up. Okay, if we look over into our bark range, we have, we don't have the U and V scale yet. We forgot to make these. Okay, so we're going to have to create U and V scale for our bark. So UV scale X. Okay, so I knew something was wrong here. So right click, type properties. And then so for our bark base, before we go into this, so let's create a vector 2. Put that right in between bark base in there, and we're going to call this UV scale. And I'm going to call this UV scale. Okay. And now, as a default value, I want this the value of 1, and I think we want 5 on there. Apply and accept. Okay, double click, go in here. Now, if we have create UVs, do we have any values? Okay, we have our U values, but we don't have any V values. Okay, why don't we have any V values? You're killing me. Okay, okay, we have V values, and then we have U values. Okay, so we should have at least something on here. So something is still not quite right. So F, V, U, V, oh, here it is. I misspelled a capital C. There's our values. There you go. We got U values and we got V values in there. So life is good again. All right, so we have create UVs. Now we've got that working. All right, let's go ahead and skin these rings. So I'm going to append a skin saw. Now drop that in there. Aha, look at that. And our branches now look like branches. And they have width. Yay! So let's go ahead and clean these things up a little bit in order to make a little bit more sense out of this. Now, in order to get our UVs working, Houdini doesn't like its U and V values sitting around inside points. It likes to have these in vertices. So what we do is we're going to promote our attributes from points to vertices. So I hit tab, attribute promote. All right, we've got that in there. So we're going to go, we go original point, and we're going to go to vertices, and then the average methods is first match. Okay, why is it giving me an error? Attribute name not legal. Oh, the original name we don't have it here. How about UV? Okay, no, it's happy. Okay, always one thing or another. All right, we've got that going. There it is. Let's continue cleaning things up. Let's add a, whenever you're doing any procedural modeling, get into the habit of dropping in some fuse stops in here, and that kind of helps clean things up. So add fuse. This kind of like gets any kind of points that are too close together and kind of puts them together. This shouldn't actually change anything that looks. And let's kind of clean things up a little bit and put in a polyfill, because this gets rid of any kind of polygons that are open. So this is just, once again, just kind of like dotting our I's and crossing our T's. Polyfill. So this cleans up any points. All right. All right, everything's looking good. Everything's looking great. Now, in order to get things going, let's one final test. And let's take a look at what this looks like, a quick UV shading. So I'm going to drag in here. Quick UV quick shade. Drop that in there after the bark end. Click it. And here we go. It's looking good. Oh, no, look at this. Okay, oh, here's a bunch of errors. All right, one thing, our texture is going vertically, which is in the right direction, but it's going backwards. So that means we need to go in the opposite direction in our UV networks. All right, so what we have to go back up into our QV, and so if we have here, and we go into this, so if I have here UV scale X, and so if we go back even further, so it's UV scale X, okay, we've got F of V, we got here. Okay, so let's go, if we subtract 1 from this, 1.0 minus all that, and is this going to get us going in the right direction? Yep, there it is. They're going in the right direction now. All right, cool. But we still got this seam. All right, gang. Let's take a look at what this seam is. We've got a few minutes here. Let's take a look at this. Let's see if we can analyze this. This is going to be tough. All right, now we're going to turn on the points. We got them on there. Now let's turn on the point numbers. All right, it goes from all the way from 0 all the way around to 7. All right, that's understandable. All right, great. But now these are in, they have vertices. So now the vertices should be able to handle this. Now when you say, what are the vertices? Remember, there are, at this point, every one of these faces has 4 vertices. It goes 0, 1, 2, and then 3. How do we know this? I'm going to go ahead and turn them on. So I'm going to here we got the number of the vertices. And so you can kind of see them. They're in green there. And regretfully, we got 3 faces here, like one on the bottom and one on the top there. So it's going from 0, 1, 2, and then 3. Okay, so how do we know which faces these are on? All right, so let's turn on the faces. We got 7. Okay, 0, 1, 2, 3. Okay, so it looks like here the UV coordinates at 7 vertex 0 should be the same at 6 vertex 1. Well, let's take a look at this. Let's take a look at our spreadsheet, go into vertices. We said 7 all the way, 7 vertex 0, 0, 0 should equal 6 vertex 1. So 6 vertex 1, and so it equals 0, 0. Okay, so that those are equal to each other. So this should be it, but what do we have here at 0? So 0, 1, 0, 0, what does 0, 0 equal? 0, 0, it's okay, at 0, 0. The UV values are at 0, 0. Okay, I have a hunch that this is going to be a problem. 7 vertex 1. Okay, 7 vertex 1. Okay, 1, 0. Okay, here we have a problem, gang, because guess what? These are at UV coordinate 0, 0, and these are at 0, 0. Okay, somebody might know how to resolve this. And I have to say that I am disgracing the Houdini gods. I do not know how to fix this. I do not know how to fix this elegantly the way I should. So, what I did was I came up with a hack. And you're going to say, oh, what hack is this? I said, I'm not proud of this. And if you happen to know what the solution is for this, for getting rid of this seam, please go ahead and maybe text me or send me email and say, hey, you joker, you didn't do this right. But this is what we're going to do. All right. Now, Houdini does create cylinders correctly. And we're going to take advantage of that fact that Houdini knows how to do cylinders. And so what we're going to do is we're going to create, for every one of these branches, we're going to create a clean cylinder that does the UVs correctly. and it's going to have the exact same topology as our thing, and then we're going to copy our UV parameters over. So this is kind of a hack, yes, but I have a hunch this is going to work. So let's see if this works. So what we got to do is go to our, so we're going to need some length information here. So for this set attributes, I'm going to go ahead and add a new value here. I'm going to use this for setting the number, matching my topology. So I'm going to have to actually the number of points that are coming in along each of these branches. So how many points are we? So let's create this length. So I'm going to go. Okay, so we go I because it's an integer at, and I'm going to just call it len, len for length. Okay, thanks, John. Oops, don't want you here now. All right. Hopefully, resolving these Houdini issues equals, okay, at num points, num pt. Okay, so what that's going to do is it's going to add the number of points along the length of the branch. Let's see if this works. Alt enter. Click this. And so if we click on it here, we should have a new parameter here for length. Ah, there it is, 20. Okay, good. That's all we need. This is like brutally simple. All right, we've got that in there. Okay, we don't need the UV SOP anymore, so we're going to get rid of this set V. So I'm just going to ignore this. I'm going to turn it off. All right, we're going to ignore that. And guess what? This whole set UV, this, guess what? We don't need this anymore. I'm going to ignore it. This is embarrassing. All right, this whole attribute promote. All right, because we're getting errors now, so let's get rid of this. All right, so we don't need these. All right, and ignore the vertex wrangle SOP. Okay, we have another vertex wrangle SOP in here. Oh yeah, okay, so we're good to go. All right, so this is looking heinous now, but that's okay. What we're going to do, we're going to clean all that up quick. So we're going to create some cleanliness. We've got heinousness, and we're going to create cleanliness. So we're going to go here. We're going to drop down a tube SOP. We've got a tube SOP, and I'm going to call this clean tube. All right, clean tube. Now for the rows, we don't want this to be primitive. We want this to be polygons, and we don't need any of this fancy stuff. So all we need is basically to maintain that right topology. So we have to adjust the rows and the columns. So rows here, what we're going to do is we're going to get the point attribute to the length attribute for the number of rows, because this is going to duplicate the length of each branch. So inside of this, I'm going to hit Alt-E, and so instead of 2 rows, this should be point, open and close parentheses, insert, double close, open and close quotes, / set attributes, and we just want the first one, so we're going to go to 0, and we want the length, cap, open and close quotes, len, and this is just length value of 1. Okay, so click apply. So set attributes, no, we want this to be / set attributes. Is that right then? Apply, yes, and so that's 20, so that's a good sign. So the number of columns, and that just depends on this value here. the number of divisions. So I'm lazy, I don't want to type it in. I'm going to right click, copy parameter. So click on here, number of columns, paste relative reference. Okay, there it is. Okay, does that equal what? 8. Okay, good. We're styling here. Okay, we've got our clean tube. So let's give it some good clean UVs. So tab, I'll go UV texture. UV texture. Okay, now I'm going to click that on there. And so for this for the type, instead of orthographic projection, we want to have cylindrical. And here's the important factor here, folks. We're going to keep this for attribute class because remember, Houdini likes its UV information and its vertices. And here's the key. Fixed boundary seams equals true. All right, that fixed it. All right, so that's clean and fine. So let's go ahead and give this back to our values. There we go here. Okay, we got our skin sop here. We're going to do a click here, and we're going to go attribute copy. I'm going to drag. Whoops. Nope. Stop that. I'm going to drag this over here. Go attributes copy. No. Attribute copy. Alright, we got here, this is going into the skin sop, and this is going from here into there. We're just totally getting rid of that bad boy. And then we got our attribute copy. And then for our attribute name, do we want to pass? We want to just pass on UVs. Okay, now let's see what we got here. Oh. What are we displaying here, gang? Okay, something went wrong here. UV texture set. Okay, I got the. Hopefully, that's all I did wrong. Is I switched the order on these. Okay, so the skin sop should go into input 0, and UV sop should go into there. All right. Okay, look at this. Almost there, gang. Oh, jeez. Okay, we got rid of the seam. We got rid of the seam, but lo and behold, look at this. It's upside down. Our U value is upside down. So what I'm going to do in order to clean this up, I'm going to, oh yeah, okay, so, oh yeah, is this right? Okay, yeah, and actually this is looking kind of stretched here. So what we're going to do here is I'm going to add a vertex wrangle sop at the bottom of this. Vertex wrangle. Okay, we forgot to take advantage of our UV scale as well. So we're going to actually solve a bunch of problems here. So click here, we're going to go at UV, and we're going to go open and close square brackets, because this is for our U value, times equal, and then CH, open and close, and we want our UV scale X, go dot dot slash UV capital scale X. Okay, and hit Alt Enter. It didn't like that. Okay, probably because we didn't put this in double quotes. Okay, got it in double quotes. How about now? All right. We got that. And is it? Oh, it's still up. Okay, that's the V value. So we got that. So at UV1 times equals CH, open and close double quotes, dot dot slash UV scale Y. And let's hit enter. Okay. Why is this? What is our value here? Yeah, we zeroed it out by accident. Okay. That's not cool. Alright, well, how did we zero it out? Oh, we misspelled it again. Jeez, that's the last time I used C in there. Okay, there we go. Okay, and it's still upside down here. Okay, we gotta get rid of that template. Alright, we got the right scale, but it's still upside down, so this should be UV scale Y. No. So we're gonna, okay, so let's just say we're gonna do this dumb. I'm fading. UV1 equals 1.0 minus at UV1. All right, let's see if that works. Yep, there we go. And we are correct. Okay, clean seams, clean bark, clean textures. Look at that. An awesome looking tree. Okay, not necessarily the most beautiful way of processing, but hey, we're kind of like inventing this as we go along, right? All right, gang, that's as far as I was hoping to get today, and we got through with it. We've got beautiful looking bark on our trees, and everything is looking good. Hopefully we learned a couple of things on how to debug some kind of problems that will, inevitably happen along the way. I will go ahead and post this Houdini scene file to the, I will go ahead and post this to the GitHub interface, and this will be up as soon as it can. And if you have any requests, please drop them by. If you have any comments, if you know how to solve this damn problem without resorting to this cool clean tube business, please contact me, because this is kind of embarrassing. It shouldn't have to be this way, but it is. All right, cool. So, there's one other thing. Before I forgot to say. All right, our bark template, our uniform scale. Okay, copy rings to points. We forgot to multiply our base width, bark base width. Okay, so how can we do this real quick? So let's go Alt E. Okay, CH times, all right, double quotes, dot dot slash bark base width. All right, click apply. All right, now, does this work if we wanted to make the width bigger? Okay, there it is. A nice fat width that modifies things proportionally. Okay, cool. Send me your requests. Follow me on YouTube. Check out the Orlando Houdini Users group. Join that, and we're going to have a Houdini Users group meeting in the very near future in order to get things established and up and going. All right, cool. I'm just about out of time, gang. We had just about enough. Send me your questions, send me your comments. I love to hear it. And I hope you're all doing great. I hope you have a great weekend. And I look forward to seeing you all again next week at Houdini Secrets Live. Arrivederci.